Hi everyone, you're very welcome to the iAtelier Expert Talk. We're just going to give it a minute or so to let everyone come in, and then I'll hand over to Michael. Thanks everyone. So Michael, I might let you introduce if you want to get started.
Yep, perfect, Shauna. Thank you. So, good evening, everybody again. Welcome back to our sixth talk in the iAtelier Expert Talk series. Again, my name is Michael McLaughlin, and I'm a lecturer in digital design, digital fabrication at Limerick School of Art and Design. Before I introduce our speaker for this evening, I wanted to mention that many of the project partners in this particular project are also involved in another project called Crafts Code. And Shauna will put some links into the chat there for you. I would encourage you all to have a look at the project Crafts Code. It's of the very similar vein as this project in introducing digital methods into crafts. So take a look at that whenever you get a chance. Today we have Tavs Jorgensen, who is an associate professor at the Center for Fine Print Research at University of West of England. Tavs has a background as a craft potter and designer for the ceramic industry before developing a career in academia. He taught more than 10 years at the Royal College of Art and has guest lectured at many leading international institutions, including MIT and the School of Art Institute of Chicago. Tavs has a wide range of research interests, including digital fabrication, glass and ceramics, toolmaking, interdisciplinary research, and independent innovation. He is currently in receipt of a fellowship grant from the Arts and Humanities Research Council, investigating new approaches with ceramic extrusion. It was actually the innovation manager from the Crafts Council UK, Alma Daskalaki, that introduced me to Tavs' work at the beginning of this project. And the aspect of Tavs' work that really drew me in was how he uses digital tools to make extremely accurate manual tools. He makes molds, templates, and formwork that can be manually adjusted in response to the material knowledge and the desired outcomes. And Tavs has been using his unique perspective as a craftsperson to explore the interface of how we use digital tools, and is applying the academic research that he's undertaking through his creative practice. So Tavs, I invite you to share your screen and you can get started whenever you're ready. And just a reminder to everybody else that you can add your questions to the Q&A tab at the bottom of your screen. And myself and Eleanor, also from Limerick School of Art and Design, will go through them at the end. So thank you, Tavs, and great to hear from you.
Thank you very much for inviting me. I'll just share my screen. Can you see that?
Yep, that's perfect.
Okay. So I'm really honored and I'm really pleased to be able to contribute to this series of talks, these expert talks. And there's been a so there's obviously some kind of headlines that to kind of discuss in these talks: the position of craft in the 21st century, the integration of digital design and technology within the craft industry from designer and makers. So this is me. I think I fit the kind of digital based maker designer. Am I an expert in that subject? I don't know, but I've been engaged with the subject for a long time. So it's really great to kind of get an opportunity to make some reflections from earlier work to the more present work. So it's kind of my perspective on the subject, and all the all the examples I will show is from my own practice. This is what I know best. So with some kind of some of my visions and views on the topic. Just a bit of background on me. I trained as a potter. It's a slide I use a lot when I give talks. It's actually not me, none of these people, but the guy to the left is Leif Wange, a guy I was apprenticed to the tender age of 16 in Denmark, and I did a 4-year pottery apprenticeship with him. In Denmark, pottery apprenticeship is still very much was very much kind of a formalized craft education. It was 4 years. You had to sign up, and you had to do an exam to become a competent potter or thrower, really. And so I did that, did apprenticeship, and I became a production thrower. And for a number of years, I was a production thrower, making lots of pieces. It's the reason I ended up in the UK. I came to Dartington Pottery and was production throwing there for a number of years. I was being trained as a production thrower. You throw quite accurately, almost like a machine. And I guess there's lots of kind of parallels and discussions that's already been raised by the various speakers already, like, industry craft. But certainly being trained as a production thrower, you're trained to be very accurate in the way you throw and consistency and all that. And through that kind of through that training at the Dartington Pottery, it was kind of a mixture between traditional craft pottery and also sort of industrial methods, so slip casting, jigger jolly, ram pressing. And I became really interested in, rather than kind of trying to recreate each piece accurately as a thrower, what the kind of precision and the kind of the perfection of designing and the model making, mold making really attracted me. And I migrated from craft pottery into design, and I started designing, and I was a designer for about 10 years, where I made my own models and essentially designed pieces for industry. So I would say I span both the maker and the designer kind of perspective of the gamut that kind of in terms of the perspectives that have been invited for this series of talk. So craft, I think it's really useful to just try and define a little bit, certainly in terms of this presentation, also for myself, just to kind of what signifies craft, what are kind of some of the characteristics of craft. And in my view, a real attention to the process and the medium is kind of the key things in terms of craft. When you're working as a designer, you are not, you are designing things, and you're not so engaged with, how they're being made and what material they're made in. It's kind of, it is more about what you're designing. In craft, you are so engaged with the process. You're a thrower. It's part of it. And the medium, you're a potter. You work with clay. You don't kind of. You don't span a range of materials. I mean, this is generalization, but I think it is really one of the key characteristics of craft, that kind of the real kind of rooting in process and medium for a practitioner. And a key thing about craft, and I really think that it doesn't happen in design, is the notion of process or medium aesthetics. So you have throwing is a good example, where you leave evidence of the process in the piece as throwing lines from the fingers, and that is, I think, it's really unique to craft. You would not deliberately leave evidence of the process in an industrial design artifact. That is really quite characteristic of craft practice, and I think that is significant to recognize. So when I started a couple of decades ago to actually work with digital fabrication, I think I took a lot of those characteristics or interest with me. So the first project I did, or the first kind of exposure to digital fabrication, was through a project run by Plymouth University, where they invited designers or makers in to explore the very first 3D printers. And there were the first 3D printers were operated with paper. They're called LOM, laminated object manufacture. And we were invited in to try these new tools as designers, and really to look at what could they be used for creatively. And it's such a kind of characteristic of 3D printing or layer manufacturing, the layers, and I made some very kind of obvious intervention in terms of using the characteristics of the process, and made a little, some little designs. Essentially, the LOM machine was a very weak powered laser. We had to cut the sheets of MDF, I think, 5 times to get through. So essentially, it's it's obviously a method that's been explored, or a aesthetic that's been explored a lot over the years, because there's such an obvious aesthetics based on the kind of layering of 3D printing, and these were the very first pieces I did in terms of digital manufacturing. Some little bone china bowls based on the aesthetics. So really using the aesthetics, just like the kind of the craft basis of kind of using process aesthetics, but with digital tools. I looked at other ways of kind of using the digital tools. The unfolding, the kind of developing surfaces is another kind of key way of making pieces, and I explored that too. Designed some shapes and unfolded them, and then used kind of very common known Pacura on paper pattern designer, where you can unfold the patterns and then make them into shapes. And it was really eye-opening for me both as a potter, but particularly as a designer, as I was at the time, where if you have to scale something up, you have to remodel it. It's a huge amount of work if you do it in plaster. But with digital tools, you can do it very easily, and you can, just by scaling things up, you can actually really explore the dynamics of the different scales at the same shape. And it was, to do that really easily was a real kind of eye opener for me. Then I came to then I fell into academia. I was invited to be part of the automatic research group. I think Drummond is giving a talk next week. So there was 4 of us that kind of where we were employed as researchers to explore digital tools. So Falmouth University had been given EU funding to set up research to explore this space, and I kind of, I was employed as a research fellow, even though I had no formal academic qualifications. But it was a great time to where we had the funding to explore some of the early stuff in terms of both interfaces and fabrication methods. And one of the projects I started with was to explore motion capture, where we, ways of using hands rather than keyboard and mouse. It was before iPad and iPhone and all the interaction you would have in terms of computers or CAD programs were through a mouse or a keyboard. And it's, coming from a craft background, it is a poor interface, because you're using your fingers and your dexterity, to a very poor extent. And so I looked into, well, we got this motion capture glove, and you can describe forms in space, and it would track it. You can see the recording on the top right hand corner, and the trajectories, you can track the trajectories from each of the fingertips, and they are there in black. And then you could create forms from these trajectories. You can create surfaces, you can loft between the kind of the rails and create surfaces from your movements. And I did a series of seats based on that, describing some forms in space and milling out the seats. So you kind of just like a hand thrown pot, essentially, where you leave finger marks. This was a kind of digital way of leaving finger marks. You're using the motion capture to capture the motions, and then you use the CNC milling machine to mill out the seats. And so it is that kind of process aesthetics. It's an aesthetic that kind of derives both from the makers, but also the kind of design approach, particularly using your hands. So I think it really links back to the kind of craft ideas, but with digital both interface and fabrication tools. Other experiments in the same kind of vein, where I used a microscribe, which then I don't think they're around anymore, but essentially kind of a digitizer, which you could use as a 3D drawing device. You can track kind of movements in space at a single point, and from that kind of line, you record the lines directly into Rhino, and you can then create a surface from that line. You can unroll that surface, so you get a flat surface. And the whole kind of idea with this is you can laser cut all of that. I mean, it's incredibly simple, and these days it's kind of everybody knows this, but if you've got a laser cut in stainless steel, for example, and the side protection and the top protection in MDF, you can then bash the whole thing together. There's quite a lot of manual kind of work in getting in that space, but then that is essentially a quite an accurate representation of the line drawn in space from the microscribe, and the outcome of this is that the stainless steel can withstand heat up to about 1,000, maybe more, 1,100, and you can use it as a former, as a tool to create glass balls. So you can support the stainless steel initially with refractory plaster. You put the whole thing in a kiln, and you put a glass disc on top, and you heat it up, and in a process called slumping, the weight of the glass disc simply domes under its own weight and gravity. It softens, it domes, and it creates a ball like that, so formed over the rim of the laser cut stainless steel. So you're using the medium and the kind of the characteristics of the medium a lot, but in combination with the digital tools, so that the digital tools really help to create the tools, but it is a real dialogue between the medium as well. And I think this is really old work, but I think for me it's really still probably what I do. I think I really focus on using the medium as an active part of the creative process, and I think that is part of the strength of the kind of craft knowledge that we know about glass and clay and wood and stuff like that. You really know what the material can do, and then if you add that kind of the power of the digital fabrication on top of that, then that really has some potential. So the whole notion of tool making, I think that is really, really significant in terms of digital technology, digital tools. Really has been a big area for me. It's something that Dries talked about the other night, and he kind of characterized tool making as quite well. I think he just showed an image of Japanese sword makers making their own tools. I would actually, to some degree, disagree with that. I think tool making is much more of a characteristic of industry. It's certainly when I was a potter, I didn't make many of my own tools. I think maybe the odd rip or kind of, but actually that I didn't make my own wheel. I didn't make my own kiln. I would and I think tool making, advanced tool making, is much more characteristic of industry. and industrial revolution or the various industrial revolutions. And I think the first industrial revolution is quite interesting to look at. That's where machine tools developed, and there's a great book called Industrial Biography, Ironworkers and Toolmakers by Samuel Smiles, and he really highlights how significant the notion of being able to make tools that can make other tools that then make other tools, the kind of whole kind of, like you supercharge like innovation by being able to make more and more accurate tools by this kind of the whole kind of tool making chain. And I think the tool making is much more characteristic of industry, but with the onset of initiatives such as like the RipRap, open source rapid prototyping, that research, which really has led to the kind of boom and the diffusion of digital fabrication tools that we now can buy 3D printers for next to nothing. That really opens up the kind of industrial innovation possibilities in terms of tool making to craft practitioners. It really made that possible, and I think that is where the two kind of knowledge domains or whatever, or kind of approaches, kind of where craft is starting to merge with industry. That tool making now is advanced tool making, really accurate tool making is now available for craft practitioners really widely, and that I think is really significant. I think it's still kind of working its way through the system. I think there's still lots and lots of potential there, but over the last 10 years, that is a real game changer, as far as I can see. It kind of happened. This project, the RipRap project, happened while I was at Falmouth at the Autonomatic. We were quite spoiled there. We had EU funding. We bought lots of expensive 3D printers, CNC milling machines, but the RipRap project happened while we were there, and we were slightly behind the curve because we had the funding to play with these things where lots of other people didn't have, so we were kind of slightly behind the curve. That actually, all of a sudden, people were making their own 3D printers and advanced CNC machines, and so we had to kind of catch up, and we started looking at it. We organized some machine building workshops, some CNC building workshop, where we put together some CNC machines, some drawing machines, some digitizers, just to kind of get ahead of, how difficult is it? It can actually be done. There's lots of things online, but actually, is it possible? Is it realistic? It's and it is actually quite straightforward, and it was really inspiring. And I got from that kind of experience, I got interested in more advanced tools and molding devices. That you can make things that are really very complex and accurate and sophisticated. And I got interested in a tooling concept or a molding concept called Reconfigural Pin Tooling. It's just like the kind of toy you press your hands into, which you can buy as a kind of novelty toy. But it's been explored for a long time as a kind of this ultimate molding tooling method where you can only you can reset it, and you can have you could mold and create different forms, and it really had it's I think people really previously the engineering and the kind of difficulties in terms of setting these things up meant that it was difficult to achieve, and it was expensive research projects through MIT might achieve some results, but I thought now with all this access to digital fabrication, I wanted to have a go with it, and so started looking at designing pin tools, and another kind of aspect of tool making, which I think is worth highlighting, is the coding and the scripting, using Grasshopper, the plugin to Rhino 3D, where you can code, you can script. This is essentially, a tool. You are designing tools to make other things. In this case, you're designing tools to make other tools, and to be able to have access to something where you can script without having to code is also a real game changer. And I think being able to make tools in that way is really very significant. Very significant for me, that you can through relatively short training, you can start making your own scripting tools to design stuff. So I did that, and this is a example of that, a circular pin tool, and then being able to use where we couldn't manufacture ourselves, or at Falmouth, for example, where things are kind of beyond the kind of the equipment we have there, to also to use the digital bureaus that emerged in that period, like laser cutting. So this is the local laser cutter that I used there to manufacture the pieces. It was also a real game changer for me, that you can get things really accurately manufactured through a local laser cutter. It's just which these engineering tolerances, which were kind of unattainable previously, 20 years ago, without kind of having a full scale engineering workshop. Another game changer. You as a craft practitioner, you have access to these bureaus that can make these things at a really high level of precision. So this is one of the tools I made, this pin tool, and I explored it with glass, just like you saw before, using the characteristics of glass, molten glass, slumping pieces on top of the pin tool. Initially, I thought I'd had all the pins there and kind of set it. I can really control the shape of the glass, but actually, it actually turns out that you only need a few pins and strategically placed pins to create a piece like that, and actually just kind of get the material and the process to do a lot of the other hard work. So you only really just need the tools to kind of really position the pins strategically to kind of create various pieces, and you can keep resetting the pins indefinitely and different kind of combinations and forms and scales, but with the material as a kind of key component, and material and process as a key component of the creative process. Same tool, but set using the pins to be set in orbits rather than randomly. A part of the kind of the idea with the tool is I guess the description of the reconfigurable pin tool as the ultimate tool, as the universal tool that you can do lots of different forms, not just kind of organic bowl, but you can set the pins in whatever forms you want, and in orbits that's much more kind of formal geometry. So the next experiment was on this next kind of range of experiments, but to see how kind of formal geometries can also be used with it. So here the pins are set in orbits, and you form the opposite way, you slump into, and you can then use again indefinite kind of combination of orbits or heights of the pins, and create pieces like that, which just sits on the balance kind of sometimes a little bit crooked like that, but I really like that they kind of they have a different slightly different find their own balance in terms of the in terms of the geometry. I guess the kind of the consistent thing here is that, you know, there is a real evidence of the process here, you know, that you know, the pins leave a mark in the bowl, and I think that is kind of consistent in my approach to making, particularly with digital tools. I think that, you know, the process really plays a part in the final piece and the aesthetic of the final piece, and I'm really interested in that, and I think it links back to the kind of craft approach or principles. Laser cutting has been around for a while, and actually, and another kind of body of work that I've been interested in is extrusion, and this is actually going back much further. I think before even Falmouth or Automatic, during my time as a ceramic designer, to use extrusion. I mean, everyone worked with pottery would have used extrusion. They're in the kind of small handle extrusion are there in most ceramic workshops, but I think it's really underutilized, and laser cutting is a great way of creating some basic profile. Otherwise, I think part of why it's underutilized is that people can't be, you know, to make a die or a profile is kind of labor intensive, and you don't want to sit there and file away on a piece. But laser cutting, it can be done quick and cheaply, and you can do some shapes straight away. So I did a series of pieces, or actually complete dinner service for a hotel, restaurant in Bath, the Royal Crescent Hotel in Bath, because they wanted the kind of special pieces or kind of exclusive pieces. If you had to do them, either you had to throw them, and they didn't want thrown pieces, but they wanted like molded pieces, or kind of design, you know, non-thrown pieces, you know, unusual shapes. And if you have to do it in terms of mold making, slip casting, it's really expensive. It's really time consuming to do the molds. But extrusion, the dies are relatively inexpensive, and you can do unusual shapes. Some of the pieces done a long time ago with extrusion. The extrusion subject has carried forth, or I've been I left it behind and got going on other things, and then I came back to it when 3D printing became much more accessible, and to explore whether 3D printing could be used for extrusion. So I did some initial tests to 3D print the dies, and initially they were disastrous. I mean, the kind of the structural integrity of 3D print for extrusion dies initially was not sufficient to work with the process. But then I started looking at kind of hybrid. So you can use part metal, brass bars in the extrusion dies, but also the reason for using 3D printing for the extrusion dies rather than laser cutting is that you can, with 3D printing, you have such freedom in terms of geometries, and you can create really kind of specific dies. And I was interested in you saw some of the pieces before that was curved, but I was really interested in exploring that, you know, how you could curve things and create, you know, the kind of geometries in the die, so it really would control the curving like that. They seem to work really well, the kind of hybrid dies, and so you can do extrusions like that, and the idea for this is really to make some. It was a a series of jerks. So you would extrude I would extrude the basic shape, then trim the base and the top to create these juxtrusions, as I called them, and some would pour, some would not, but it was a really interesting project to get back into utilizing extrusion and the 3D printed dies. What was very interesting with extrusion generally is that it's really quite complex, the way the clay moves through the die, the rheology, as it's called, of clay, the clay paste through the die is really hard to predict, and it's really kind of complex, and it would be from one extrusion to the next, it could be really quite different. So it's really kind of what is going on there in terms of the kind of fluid dynamics was really interesting, and I came up with a kind of a title for this, or a kind of I don't know if a manifesto, but a concept, the notion of technological indeterminism. Where a way of sort of setting up using advanced digital fabrication tools to create tools or manufacturing processes, which through the use of particular manufacturing mediums creates artifacts that cannot be fully determined and thus have unpredictable, interesting qualities. So I guess it's, it is a lot of the kind of the other work I've shown that the medium has a real kind of role to play, and can play a real kind of unpredictable role. So the kind of notion of setting something up that you're using really accurate and advanced fabrication tools, but actually the outcome is quite unpredictable because you're using mediums and processes that does make it quite unpredictable. That's my kind of take on it. That's my term for it: technological indeterminism, as a notion. And it sort of, to move on from that, I think just taking a key notion that from this the invitation to this series of talk is part of the invitation is to draw views from us that are presenting views on the integration of digital tools and technology within the craft industry. For me, it is much more interesting to maybe go to industry, to actually what can we as craft practitioners contribute to industry, to other disciplines. How does that work? How can we, how can that kind of transfer of knowledge best work? That is a really key interest of mine right now as a craft researcher. So the kind of how craft knowledge can be applied in industry, how can that kind of that work, and that is, that's a really big interest of mine, and I and the next kind of few slides is really, that is kind of my take on it, and my kind of my approach to that. So still staying with extrusion, and extrusion is used in craft, but it is used actually much more in industry. It's, pretty much all bricks used these days would be extruded. That is the kind of, that's the way bricks are manufactured generally now, because it's a really efficient way of just making mass-produced bricks, but not also other ceramic architectural components for roof. So extrusion is used a lot in ceramic in architectural ceramics. I should say that when you're trying to kind of implement stuff into to industry, and if you're trying to get money, you particularly for research grants, so, you know, I'm an academic now, I'm a researcher, you really have to look at what the industry what the government wants. Essentially, you know, research money it's political, and the way the research money is allocated is you know, kind of crudely follows what the government wants, and when you have to write stuff, you kind of have to align it with something like, in this case, an industrial strategy, which the UK government use as a document to say, you know, what do we prioritize, how do we grow our industry. And so if you want money to try and do stuff in the industry, it's really, you need to look at these things, and you generally have to kind of also partner up with industry before you try and get money. And I partnered up with some really big industry companies, Arabs, Belkin and Wienerberger, are really huge multinational companies that, you know, by bothering them and calling them and kind of keep borrowing, you know, they what you need to get is essentially a letter of support and a commitment to kind of give you some time or materials. They have to kind of state that, you know, like, we're going to give you like 10 grand's worth of materials or 10 grand's worth of time. For them, it's absolutely small fry, but you need to get that commitment before you can apply for funds to actually, apply for research funds. And then you have to write these enormous applications, and I did, and I was successful. And so I'm, you know, a big thank you to the Arts and Humanities Research Council to recognize the kind of the notion that it was of value to use my craft experience in industry, and that was really written throughout the application, that, you know, the experiments and the kind of methodology was as a craft practitioner with industry partners. So I had money, and I still have money to research, you know, how can I, you know, transfer this knowledge in terms of the kind of extrusion experiments that I did as a craft practitioner into industry, and looking at what there is in terms of extrusion in industry is interesting. The dies, the extrusion dies that are used in industry they're either really crude, they are really kind of just, you know, big chunks of metal, just, you know, cut out section, or they are very sophisticated, but only sophisticated in the sense that they are built for absolute mass production. So the whole kind of all the tubing and all the kind of the dials and the knobs and everything is there to lubricate the die, so you can produce bricks by the millions. So this die, this tool head is sophisticated because it does one thing, and all the kind of lubrication channels and stuff like that is to make it last for a long time, not to create kind of interesting shapes. It's really just there to kind of make it work for a long time. This is what typically extrusion, you know, it just kind of runs for days, weeks, years. This machine here from the Wienerberger Sandhof site, I think it's been sitting there for decades. That's how, you know, they really run, you know, standard for a long time. They're not, you know, the industry traditionally is not, you know, hasn't been that interested in innovation in it. They are just there to kind of produce stuff efficiently. So my kind of interest was, you know, how can we innovate? You know, what other things can we do with the process? And I think the industrial partners could see that there was, you know, there was room for innovation, or there was room that other new thoughts in terms of the process could fit within. So one of the first kind of issues in terms of being able to do research for industry is to actually get an extruder, but they are huge things. They are, industry generally doesn't want to stop them. They want to kind of keep them running. So the industry is very happy to kind of support other research, but they don't want to disrupt the production. So we needed to get an extruder, and so that's what they look like. Yeah, this is from a company in the state, Boston Valley Terracotta. We needed to get an extruder, and we bought an extruder from the States, the biggest extruder we could get without kind of going completely in, without blowing the entire research grant extruder. So the biggest kind of semi-industrial puck mill extruder we could get from within a reasonable budget, and so we imported it from the States, and as soon as we plugged it in, it blew up. The supplier or the importer, despite us kind of querying them, didn't realize that not only single phase is different in US from Europe, but also three phase is a different So it just went bang, and we were left with nothing. So another thing I think in terms of the craft practitioner as a researcher is that I think it is widely recognized that the resourcefulness of craft practitioners is a thing, and we're good at making. So I think the kind of go-to thing when something goes wrong is just, okay, we're just going to make something. And I guess all the experience from starting to build CNC machine and kind of my own sort of advanced tool making in terms of glass projects also came into this. So even though that a extruder is quite a step up, that is kind of heavy engineering, I thought, okay, well, we're just gonna, we'll just have to make one. So using what we had in terms of unistrut, discarded unistrut that was just lying around, just make a frame, just build it. I think that's another characteristic of craft, that you don't decide. We didn't design this. We were literally just making it. We didn't, just kind of. And I guess with unistrut you can reposition things quite easily, and it's a bit like Lego. You can just, if that doesn't go there, then you put something else there. So it was great to kind of get the frame going. The old friend, the laser cutter or the laser cutting bureau, to get some flanges done in stainless steel, and then just buying stock stainless steel pipe. I don't know what they're used for actually, but this is the kind of the big stainless steel pipe you can buy, like readily made, just by the meter. And I think it's metalforus.co.uk that's the biggest they supply. I just bought some of that, and some bad welding to get the flanges on, and then that's the barrel, and then getting a hydraulic system going. I kind of known of hydraulics from the previous experience with extrusion, but I've never kind of made one, but actually looking at some YouTubes, and then we thought, well, we're just going to try and get one in, and then just see whether we can get it going. And it's really quite simple, and it's relatively cheap, because hydraulic is used absolutely everywhere. And so, hydraulic cylinders and hydraulic power units are really quite cheap. You can get it quite cheaply, and so we just got it in and got it going, and kind of just and it seemed to work well. And then we put the whole thing together, the frame, the barrel, the hydraulic power system, and the extruder was kind of up and running. We also used 3D printing a lot for some of the parts, it is a really it's actually a really good tool making medium. So some of the kind of bits and pieces parts we do with 3D print rather than get laser cut, and this is the kind of the piston head printed in PLA, standard PLA. Worked well, and it worked. It really worked very well. So these are some of the first kind of extrusions, and it was great. We could get it going, finally get going with the after months of delay and with the experiments. The use of Grasshopper tool making through scripting has kind of developed a lot from their first kind of crude experiments and kind of quite sophisticated. They're called definition, the scripts, the visual scripts are called definitions. We developed, and so the dies, the extrusion profile, the dies could be done entirely through setting some some diameters in the Grasshopper script, and so really you don't have to kind of manually design the dies. Everything would kind of be automated. You can just import a profile or set a diameter, and all the kind of parts would be generated through the script and then you just 3D print it. And we use really cheap 3D printers, but partly as a principle, because they are actually just as good as the more expensive ones. And also part of the project, part of the research was also to show that the diffusion of cheap tool making tools like the cheap quality printers is really quite significant and can enable craft practitioners to innovate or engage with industry. So it was a bit of printers. So the printers we used, like 500 quid printers, 200 quid printers, and we use big nozzles, and that's a key thing as well, that these kind of tiny nozzles that it takes forever, but big nozzles, sometimes you really don't need that fine resolutions. You need that the 0.8 nozzles or the 1 millimeter nozzle, and then you can make the dies quickly. And we used standard materials by and large, certainly initially, to print with. The standard PLA seemed to work fine. So these are the kind of kits that we print out, or we do print out, with all the parts there, the what's called the bridge, the nozzle, the pressure plates, spacing, feet, and then a bit of a hybrid with just using stainless steel bolts to put the whole thing together. So these are some of the dies that we're using 3D printed, and it really is the kind of there's certain strategies in terms of dealing with the pressure. We've broken many a die, but you start to learn where the pressure is applied and how it and they work. Oh yeah, just to compare that, these die in terms of material cost, maybe 10, 15 pounds, 20 pounds. Compare that to what the industry uses, really heavy metal chunks for the dies, and so you can change the forms and the dies really quickly. And I think that was kind of one of my aims with the research, that you could show that you can 3D print stuff and you can change the shapes really quickly, and that would be a real advantage in terms of creating different forms with the extrusion process. And the work, there you are, that's one of them. It's a small scale, and with high pressure you can actually see some of the clay coming out there on, so the pressure can be really quite high when you extrude, and also big ones like this. So it works on various scales, and we also started getting. I mean, what's exciting about, I guess, 3D printing is that while we are using really standard materials, generally. There's also some really exciting innovation going on in terms of the hype, like the glass in reinforced nylon, carbon. So we're also starting to look at that and explore that to add even more strength to the dies, particularly when they're more complex dies, like this multi-core die, again using Grasshopper as a kind of a tool to create all the inner cores. So this is a die for that for this shape here, and this is quite an exotic one with nano diamonds, which actually print really well. This is the final die here, so the inner section is PLA with nano diamonds. The outer one is nylon with carbon fiber. So we're looking at really utilizing these more specialist filaments for really high pressure dies. These dies here really need a lot of pressure to, when clay gets pushed through a matrix like that, all these sides here drags on the clay, and you just need enormous. Some of the dies really need enormous pressure. I don't know if you can see the die on the left there. It's reading 100 bar, and 100 bar is a hell of a lot. A hard bicycle tire is 7 bar, and this is 100 bar. So it's it really is a lot of pressure. And actually, at times it was so much pressure that we actually our extrusion machine kind of self-destructed. It literally just kind of fell apart because it was just kind of pushing itself to bits. We had to kind of strengthen the frame to deal with some of these really high pressures that we were using. And we've exploring these different materials, and with 3D printing, you can some of these materials that are quite exotic and would be the domain of very advanced engineering, is now available as filament for a consumer 3D printer. So here's a different range. I think it's PETG, carbon fiber, nylon, various things, and we would simply just put it through the kind of test, and most of them would, or a lot of them would, absolutely disintegrate, and we could really see, that it was, the test was really, how would they stand up to this kind of that pressure of the extrusion. And I think that is, being a researcher and being able to kind of draw on different knowledge domains is interesting, and being part of Center for Fine Print Research, where we have different kind of different skill sets. We have physicists, we have theoretical physicists as part of the team, and one particular physicist, Damien Leach, is sadly now left and gone to University of Nottingham, but to get a completely different perspective on what we are doing. So we kind of got him involved, and he could, which I never realized you could, but you could actually calculate the kind of the complex rheology, the complex kind of movement of the clay through the die. So this is a cross section of one of the dies. And he would have, he'd say, oh yeah, this is really nice math. This is really kind of nice physics. You could then calculate particularly what would be the optimum taper, or the kind of lead in for the clay to move through the die. And it was really fascinating to work with him to kind of, can you theoretically kind of predict how things are going to move and extrude and push through? So we had lots of interesting discussions with him, and he did some of the calculations he provided in terms of some of the extrusion dies that we used. Our approach sort of and in parallel with the work he was doing is to do this, to how do we understand how the clay moves in a barrel, for example. And this is what we would do as, from our kind of knowledge base. We would, create, we would make 5 holes in the die and then extrude and then see which extrusions were the longest. And clearly the longest extrusions were where the flow of the clay was fastest, and the clay would move quickest. And it is significant in terms of extrusion. Again, coming back to kind of the rheology or the kind of complex move of the clay in the die. It's really hard to predict. With unusual shapes, it does weird stuff. This is a little profile for a louver for a window, and it just, you think that's fine. We'll test that and extrude that, but it kind of the way that the clay moved really, it just moves much quicker, and it's really hard to predict. And you can this is what happens when you just keep going, and it sort of can create ripples, because it's kind of, you're stopping it. They're really beautiful, but it's not really what we what we want. But quite interesting that from the process, I guess, coming back to some of the process aesthetics, but not really what we and you can get over it, and you can get it to kind of flow, right? And these have just been extruded and no ripples. But then when it dries, the curve comes back, because you've added more clay to one side than the others somehow, or it's more dense, and then it just it'll just crack and curve. So it's kind of inherent in the extrusion, and it's one of the key. It is what industry is really concerned about this, and that's they have it's kind of a bit like the dark art in the industry, to kind of make sure that you can extrude straight, and it's called balancing the die, that it's extruding the same rate throughout the die, and you're not forcing clay into one area more than the other. So we with the way that we kind of try to fix it or explore that, partly through the work of discussions with Damien and other, but also just to test, see how can you manipulate the clay in the die. And this is some of the tests we do, like a kit to explore it and see how we can balance the kind of clay flow in the die. And with 3D printing, it's really easy to kind of do a series of tests or kind of like kits that you can test with, and we got over it. We really managed to produce really straight pieces. So these are the louvers here. I think you can see, particularly on the image on the right, they are absolutely dead straight, and stayed absolutely dead straight through the drying and the firing. What we kind of currently working on is we are due to be at the Ceramic Biennial in Stoke in September. We're really excited about that. We've been working with Sarah Fraser, an artist. She's interested in coping stones, and so we're kind of looking at extruding coping stones. She's working with kind of community art groups to track journeys, and so the profile of the coping stone is a journey of a particular participant. They kind of map that on a map, and then a coping stone will be extruded in terms of that particular profile. Some of them extrude really well, but some of them extrude really not well. They create these kind of tearing and ripple, but we think it's really beautiful. But it's not really, again, it's not really what we want to be able to produce them without this ripple. And we've been working on lubricating the dies, just like the industry. So in some ways, we're kind of going, we're replicating some of the things that industry does, but with from a crafts perspective and with digital tools as well, which is not being done. So you can lubricate the die with water to kind of create a much more smooth smooth surface, and we've been doing these so these nozzles with lubricated which are lubricated to create a better surfaces. But what which we're very excited about currently, is that we, rather than lubricating them, we also slipping the surface. So we are creating, we're putting clay slip in the lubrication, so you can create different colored outsides. I've literally just rushed back from an experiment where we've done successfully. This picture is kind of one of the early experiments where we didn't quite cover all the surfaces. Actually, well, one of the feed-ins I forgot to put the hole in the rhino file, and so it's blocked. So it's not actually feeding through, which we didn't realize until we actually came out. But we literally just done a shape with an inner and an outer, and we've been able to create coating both the outer and the inner space with slip. So we're really excited about that, and that's never, to my own knowledge, has never been done before. To be able to kind of put a different surface slip while you're extruding. A lot of what so a lot of these results have I'm kind of feeding back to my project partners, but it's also through kind of dissemination and open days and stuff that other sectors have kind of become interested in what we do, and currently we're in discussion with the National Composite Center, which is a really high-tech research and innovation center just outside Bristol. Well, as it says on the tin, that is, they're really interested in composite. But their kind of power base is kind of the aerospace industry. They are, they have capacity to do complete airplane wings from carbon fiber and all that. This is kind of what it looks like inside. But they're really interested in the extrusion experiments that we're doing, because they are, they have I think what we don't realize is that in coming from a kind of craft practice, we do experiments quite quickly and can get to new areas. So particularly with the kind of the coating area, coating stuff inside and outside, and the kind of the whole kind of knowledge in terms of the extrusion is new, and it's new, and it's knowledge that they don't have to have amazing knowledge in this sort of thing, in terms of carbon fiber and kind of, but they really don't have that knowledge. So the current conversation is that what we are doing currently in terms of the extrusion actually has real relevance in aerospace applications, potentially also in the nuclear industry. I'm still a bit skeptical that whether we can still contribute to that, but they are really serious about that what we are doing is really of relevance and can contribute to what they know. And I guess that is what I really, that is my my vision, or my aim, is really to kind of show that from what started as kind of experiments with funny jugs actually has some real relevance in a completely different context. So from that to the National Composite Center is really that, and so hopefully we will really get there, and we can contribute to what with the knowledge that we are generating with the experiment currently. That is really the aim of the big aim of the project as we go forward. That's me done. I really want to highlight the Arts and Humanities Council that's funded this research, that showed faith in this. Research England also provided a bigger grant from for CFPR, Centre for Fine Print Research, that facilitate craft research I'm part of University of the West of England and CFPR, and so all of these institutions really needs a big thank you to support and acknowledge that craft research is really relevant in terms of craft, but really valuable as a source of knowledge for other sectors and other applications. Thank you.
Thanks a million, Tabs. That was it's great as a fellow academic. It's very inspiring to see and hear of your success of your research and how much influence it's having. And I hope we have inspired today craftspeople who want to be involved in research, but maybe in some ways, more importantly, the institutions to recognize the research that craftspeople and artists and designers and makers are doing and how important it is.
Yeah.
So thank you very much. We'll give you a 5-minute break and then we might come back with some questions then if you're happy enough with that. So,
cheers, thank you. Thanks.
17:11 now, so we'll come back at 17:16.
Yeah, brilliant. Thank you. Cheers.
Hi, Tavs. Welcome back.
Yeah.
We have a couple of questions from the audience there, but I might start with one of my own first, if that's all right.
Yeah, that's cool.
I completely sympathize with you when you were saying how you bought the extruder and plugged it in and it went bang, because before this particular job I'm in, I was the manager of a fab lab here in Limerick.
Okay.
All of our initial tools were homemade built tools. So we scraped together enough money to build 3D printers, build lasers, the rest. And then we finally got enough money to buy a good machine, and we purchased a CNC router from, at the time, the best value was in the States. So we bought one from the States, put it together, plugged it in, and bang, and the whole thing went up in smoke. And I thought it was our fault at the beginning, but actually it was the wrong electricity. But in terms of building tools, I suppose you've shown that you've been building tools there, and I would encourage everybody that's listening to us to get involved in building tools. But could you explain a little bit about your knowledge, or maybe even lack of knowledge, in mechanical engineering before you started building tools? Did you have any like qualifications or anything in that? And maybe just in a way to encourage people to get started if they are interested in getting started.
No, I have no qualifications whatsoever. I think it's important to seek help in your network. I nearly put in a picture of so I, as part of my research grant, I have a research associate, Sonny Lightfoot, and really I should, I need to he's a big part of the project. I really need to acknowledge his contribution. His background is fine art, so we're both kind of creative practitioners. But when we bought the hydraulic, we bought it on the back of a Colin Firth video. I don't know if anybody know Colin Firth. Look up Colin Firth. He like makes mad videos. He's a YouTuber essentially, and he makes and it's like, don't try this at home. It really, but on the back of his one of his video, we just bought a hydraulic system, and we were really quite well, we were a bit nervous about it because and then we Sonny's dad, he was he's retired now, but he was a truck mechanic, and knew a bit, and just kind of got him in on a day, and then just try to get going on it. So really very I don't have any qualification, but I really think it's work. One of the things is ask around and get help from people that might be able to help you. And in your network, there's probably something someone that knows a bit, and so share your I'm into the idea of kind of open source and being able to kind of ask the community, and I've never really done it in an online way where you kind of post questions in a forum, but probably we should do that, but we haven't. But in a physical form, I think it really works when you just kind of, does anybody around here know about hydraulics? Does anybody around here know about blah, 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 blah? So really use your network to and people are really genuinely really keen to help, and if they have some knowledge to pass that knowledge on. So I think that's a really key thing. And
I would encourage people to involve themselves in the online forums as well, and everything is there open source, and if there's maker spaces or fab labs in your local area as well, they're full of people who just want to help, want to be there making things and want to help. And there are huge amounts of projects out there that if you want to start a little bit smaller, a little less pressure than 100 bars of pressure, when that might be a little bit high end to start with, but there are plenty of small projects in terms of building 3D printers or building smaller machines. But I suppose what I'm trying to say is, anybody that's interested in it, I would encourage you to go for it, even if you don't
absolutely
building them before.
I think what the online resources, and I really wanted to be more involved in online community. I just haven't had. I don't, somehow I haven't. But it, just as an inspiration, I think it's really important to see online, people post projects, and you can see, oh, well, so and so has, done it. So let's have a go. And so as a source of inspiration, I think it's really important too, just to see what's out there.
Yep, I'll let you jump in there now, Eleanor.
Sorry, thanks a million, Tavs. That was, it's amazing actually to see your kind of almost circle of being what you consider almost an industrial maker.
Yeah.
Being a crafter to being your relationship back to industry again. And actually, I don't know, it's an area that there's probably a huge amount of space for crafting people and their methodology for testing and trying out stuff and failing
yeah
and learning from it. I can imagine. I'm going to just jump to Claire Haley's question here.
Yeah.
If the extrusion process is so unpredictable, what techniques does industry employ to control the output?
It's all very heavy. So it is very unpredictable, and it is a bit like the dark arts. There's very little sort of, even in science, that there's very little literature in terms of how to deal with the complex rheology. There's only one real book on it, extrusion as such. They use like baffles, which they screw into the extruder to block the path of the clay before it hits the die. So you can kind of it's called balancing the die, but it's really heavy engineering, and it's just part of what we wanted to do is to propose some methods where you don't need to, like a £500,000 extruder or an engineering department to innovate with this process. So they essentially they use like big metal rods they screw in to block the flow of the clay. But it is, as far as I know, trial and error, and it's really hard to kind of predict. And they're very secretive about it. They really are. Extrusion in particular they're really sensitive about that process, because it is there are relatively few companies that do it and do it well. So they are quite protective about it.
A part of my question is, I suppose they actually do fail. You just never see the failure. So there's actually the myth that every brick is the same, whereas there's not this kind of quality control, and some bricks just don't make the cut.
well, yeah, I mean, the Wienerberger, which is one of my partners, their big site in Sandhof, they had problems with the roof tiles, and just like our results, where you could extrude something perfectly, it's straight, and then it would bend and crack later in the drying, and they have the same problems. And they kind of, some of the loss rates are, and I think at times they don't quite know what's going on in the system, but at times they just they will take those losses rather than try something different in the production line, because it's expensive to stop it. So we are in a phase now where I think we can go back to them with some suggestions of how to remedy some of their, and it'd be really great if we can actually help them. A multi-billion-pound company with a couple of a craft practitioner and a fine artist can actually come up with some knowledge that they can actually use, and that would be my, that would just be great. So, but I think we have some ideas of how they might be able to solve it. Some of their problems they have, but yeah, as you say, they don't often, or they don't always show it.
I think there's a good few practical questions, Tabs, about the processes that you've been doing. So one here from Kato Kelly. As a fellow extruder nerd, I really enjoyed the presentation.
Sure.
I have designed a die to fit a standard North Star wall-mounted extruder, which I'm planning to print with an SLS printer.
Yeah.
It's a solid profile rather than hollow, drawn in Rhino, like yourself.
Yeah.
I lofted and twisted the profile to 20 millimeters, hoping to produce twisted coils. Do you have any tips for the printing? Thank you.
Just go for it. I think it is. I mean, what our result is our approach is to test practically, not to be just to test rapidly. I think don't fiddle around with fine-tuning stuff. Get some clay in your profile and see how it works. Then do iterations. I think that is that there is a. I mean, I keep banging on about, and didn't include in this presentation, but there is the cult of done. I don't know if anybody have heard of the cult of done. It was written by Brie Pettis and somebody else. So Brie Pettis was the founder of the of Megabots, and the cult of done is sort of, there's a sort of 10 commandments, and really it's just kind of just do it. You just test, do practical tests and get results back. To try and do too much proprietary work to predict something can take much longer. I think I really believe in the kind of quick and dirty test to get some response back from the material and the process, and then iterate after that. I don't know why you would. I mean, SLS printer, fine. I mean, we use really cheap FDM printers, and they are just as good. So, but I mean, if you've got a SLS printer, fine. But I would maybe buy your own little Creality Ender, 120 quid, and then just get some profiles going, so you're not too precious about it.
I agree. And for anybody who hasn't started, say, digital drawing and hasn't sent things to 3D printers yet, I would draw the simplest thing as possible and go through the whole process so you understand it and see that it is not a complex process. And then you can start spending time, more and more time drawing and making more complex things. And so just fire into it and make as many of them as required. Yeah.
And I think that is what we can do as craft practitioners, that science struggles with a bit, and industry, that we can do tests quickly, rapidly, and get results quickly. And I think that's something really to recognize as a good way of developing and getting knowledge.
And often our field tests are the ones we like the most.
Absolutely.
That actually leads very well into Diego's question, which is, do you find that craft-based practice and development is often not considered a formal way of doing research?
Yep. I'm not a natural academic. I'm a craftsman, I guess, even though I'm associate professor now. I'm not quite sure how I ended up here, but I'm not, naturally gifted as an academic. And obviously my role entails writing papers and giving and articles, and it can, particularly when you're working in interdisciplinary space, it can be really tricky sometimes to get things published. I bang on about the craft kind of, the quality of craft in the value of craft knowledge in science and industry, and so often you fall between the chairs that you want to publish in a science conference because you think it's important, and they kind of look at you with bafflement, and you think, well, where are the graphs, and where the theory, it's not, you cannot, quite often in when you've tried to publish in that world, it's kind of, you can't just show a practical results. You need to be able to show the theory behind that result. So how, physics, what are the physics behind it, you're doing it that way? And I can't do that. I mean, we can work with, people like Damien to do that, but it can be really difficult to do. And even also the other direction, sometimes, we try to publish in craft conferences, and if you start mentioning industry and that you get a real, I've had papers rejected because there's too much industry, there's too much science in your paper. We've got a craft conference here, we want craft stuff. So it is a real problem falling between the chairs, and and that interdisciplinary area is tricky to function in. But I think it's really important, and I'll keep on.
The institution that you work for right now, or the institution that you did work for before, Falmouth, have they a particular interest in this area, or is this something that you're driving yourself, or is there like a group of people around you working on it?
Falmouth is all gone now. I mean, Drummond will be giving a talk. I think it's next week. We were a research unit set up there, a research group, and we were, essentially we were. Drummond moved into teaching. The rest of us got the boot. Essentially we got, they closed us down, lack of funding. I think it was really significant at the time, and we're really grateful for the support of Falmouth. But they changed direction and just didn't. They closed their craft course, so that kind of says something about it. So obviously we were, we weren't needed. UE, I think it really needs a bit of recognition. I think they are, University of West of England, they are really supportive, and Centre for Fine Print Research is, even though it's a very curious title for a research centre, is really moving forward in terms of craft and 3D as well. It's not just, it's everything, take print as a kind of reproduction, or kind of something that you, in the widest possible kind of notion. So there's quite a big group now. We were lucky with some significant research funding. So we've grown to about 25 kind of research staff. So that's quite a significant research unit. We're just moving into new labs in a couple of weeks' time, with lots of kind of making equipment and stuff. So they, it really is in our kind of strategic plan to do research in the craft sphere.
I'd love to come visit sometime.
Absolutely, really welcome.
I have a question here from LK Weston. Did you ever find that the material could follow the digital manipulation more, or not enough, and had to change tools or even give up with particular materials? Thinking about the glass experiments.
Yeah, I showed the successes. Didn't show the failures, but it I think it was a bit of a roundabout. I think I got into glass because I had the idea of these, that drawing the lines in space, and so the interface with either the the motion capture or the microscribe, and what material would work with that. And that's how I got into slumping and glass. That I thought, yeah, glass. So it's kind of in that regard, it was kind of finding a material that would work with that idea or that concept, that it would flow, it would do something without being like. I did some pieces in ceramics as well, but ceramics kind of with slip casting or throwing or any, it kind of, you have to do all the, the clay just kind of, you poke at it and it stays poked. It doesn't do, the poking itself. Glass does stuff when it's in, being hot and under gravity. It's got a life of its own. So it's kind of more interesting to find a material that would do stuff under its own. It had a mind of its own. So it was, but there's lots of massive amount of tests that went wrong, and but I think I did have a vision or an idea that it would work with the kind of slumping process before I'd never done any glasswork at all before that project, and I kind of had the idea, that would work, and just and it, after lots and lots and lots of work, it did work.
Like any material, you have to learn how to use the material.
Yeah.
No matter what process it's going to be, just experiments will do that.
Yeah.
Roland Smith asks, is it possible for small independent makers to contribute in some way to the sort of R&D you described, or do you need to be working in academia, do you think? And that's a really good question.
I would certainly hope so. I mean, there's plenty of examples of that. I think Jonathan Keep is a fantastic example of that. He pioneered ceramic 3D printing, more or less, and I think his approach in terms of open source is really admirable. Actually, sharing his knowledge and being really open about it has been a business model for him. And I think it's important to look at open source as a business model more than just kind of you giving stuff away. But for him, it's kind of been a calling card. I show you all I can, all I do, and actually people still want, well, great, I could do it myself, but actually I'll rather pay to go on a course with Jonathan Keep or so absolutely. I mean, it does help to be at a research unit, and you get funding and that, but the tool, I mean, a big part of the first sort of 10-15 years of my work with digital fabrication tools, my income was from craft or design. I wasn't an academic at all, and I really think the digital tools enables independent creative practitioners to innovate and to create their really new tools and new processes, because it becomes really accessible and affordable. And there's massive examples, and it's sometimes it's quite hidden. I know lots of craft people that are really, really successful financially, and sometimes they kind of, we got, some of our process involves getting it laser cut, part fabricated, and that's fine, absolutely fine. But it doesn't sometimes it doesn't sit with the kind of, you have to do everything on an anvil and a hammer. But actually, I think that's what's exciting, is that it can facilitate viable small scale creative practices, whether you call them design practices or maker practice. But I think it really, really can help. I really do think it can help. And there's plenty of examples of it. Furniture makers that get the CNC machine in-house, and then can make them much more viable in terms of their production. So that's absolutely. I think that is what it's exciting, that it really, really can help to facilitate viable production, small scale viable production.
And to add to that, I suppose Roland's original question was, do they need to be in academia? No, I don't think so. And everybody that's part of this project in some way is helping, because we're going to be at the end of this project exhibiting all the work that has come from it. So some of us are part of academia, but not everybody is. And by being able to exhibit all this work and showcase it within you know, within academia and external from academia, we're building up this profile, and we can get more funds to be able to help more people do this then as well. So everybody's helping that's already in the project.
Yep.
We won't keep you much longer. I think there's one or two other short questions.
Yeah.
One from Charlotte. Charlotte said she didn't catch the name of the cheap 3D printer, so it was the Creality 3D printer that.
Creality, they're here. Yeah, Creality we like, but there's many others. They're generally all pretty good.
And I would suggest if people are interested in starting 3D printing with their own machines as well, look up Prusa.
Yeah, Prusa is a great machine. Also, really affordable. I mean, some of the really cheap ones and Creality is really, you will, like, there can be problems, but there's lots and lots of online. There's like a real, there's thousands of these machines out, and there's a real community that kind of, and that's how we kind of, lots of our knowledge comes from these communities to make them work really well. But we use, the cheap, we use quite lots of 120 quid machines like Creality Ender, but there are so many really good machines out there. Creality is what we use, but they just change, as but the bottom line is it's incredibly affordable. You can really you get very good machines for next to nothing.
I think that's all the questions we have, Eleanor, is it?
I think so. I'm worried that our translators are in different time zones with different COVID restrictions, so we probably.
I found that extremely inspiring, and it's great to see, as I already said, such good research being done as part of academia in this area. And I think one of the things for me anyway is I'll be sharing this with management in our own third level institution. So thank you very much.
You're welcome. It's great to be able to. Sorry.
I hope you come back for the rest of the talks.
Yeah, absolutely. Yeah, no, but yeah, I'm really grateful for the opportunity to give my my perspective on this, and it's great to have a European-wide initiative. I said that before we kind of. Before we started off, and I really think a big thank you to all of you to kind of creating this this series of talks and kind of to expand this crafting Europe much further. I think there's real potential in that, and it's so important culturally to do this. I think it's so important that we have we have that kind of that element, that production, and I think that is what's exciting about digital tools, that we that can facilitate a viable practices in this space.
Brilliant. There's loads of thank yous and brilliant.
Yeah, very well received.
Thank you very much.
Well, thank you. See you soon.
Guys.
Yes, bye.
Bye.